Good morning, Sir Michael. We are from Group 2, and today we would like to present the Smart Convenience Store. My name is Tan Mehan. Now I will present the background study. First, Smart Convenience Store is a concept of manage the convenience store by using modern information and communication technology. Second, the rise of the Smart Convenience Store has given a more convenient and easier buying experience than the traditional convenience store. There are many technologies that can be applied in the convenience store fields to enhance the efficiency and productivity of the convenience store procedures. Third, the major force that drives smart convenience store is the Internet of Things (IoT), which is the concept of connecting the smart device sensor and camera that will be integrated into the store to make the store process data-driven and data-enabled. Fourth, there are several common technologies available to integrate with the store, which include computer vision, sensor fusion for the purchase, checkout, and payment step associated with a retail transaction, and deep learning algorithm. Now, I'm going to talk about the problem statement. There are few problems faced by the convenience store. First, it's quite time too long for those busy person who is running late. Second, high rate of physical interaction between people at the traditional convenience store. Third, additional manpower for cashier. Next, I'm going to talk about the objective for this proposed solution. First, implement an automation checkout sensor at the exit of the store so user can just grab their item and walk up to the store. The amount of the item will automatically pay by the user. Second, cameras on the top of the store will analyze and compare face for checking in, checking out, and add to cart. Third, all the automation sensor can replace and reduce the additional power of workers at the convenience store. Now, I'm going to talk about the architecture diagram of smart convenience store. First of all, when the user walk into the store, the camera sensor will collect the facial data from the user. The facial data information will be collected in AWS IoT Core, and it will keep storing in AWS S3 bucket as a log file in order to track the information in future. Then the AWS S3 bucket will send the data to AWS Lambda and trigger the recognition video. After that, the AWS recognition video can detect and compare the user's face that stored in the S3 with the user physically walking into the store. Besides that, the AWS recognition video will send the collected data to 3 AWS Lambda, which are check-in, check-out, and add to cart categories. For cameras at the entrance which detect user walking in and the face similarity is high, the respective cameras trigger either one of 3 lambdas. Check-in lambda track which customer is currently in the store in the tracking DynamoDB. Check-out lambda track which customer leave the store. It generates a receipt based on their purchased items and charge them accordingly when they check out. Add to cart lambda works together with the weight sensor lambda to check which customer take which product from which shelf and updates the user cart in tracking DynamoDB, as well as update the product weight in weight DynamoDB. Furthermore, in order to visualize the data storing in DynamoDB, some extra services that are needed, such as data pipeline. The table stored in DynamoDB, such as the daily product amount, will be exported to another S3 bucket by using the data pipeline. Lastly, the data storing in the S3 bucket will be processed again in Amazon QuickSight and perform data visualization. Thank you, that's all my presentation. Now I would like to invite Yong Senji to continue the presentation.
Good morning, sir. My name is Yong Ji. I am from CS and my student ID is 180042. So today, I am going to present our DCA reports and also menus as well. So now, let's start our detailed review comparisons on 11 cloud technology. Here, we are comparing the 3 clouds which are AWS, Azure, and GCP. In terms of service required in this project, their pricings and their coverage. So now, it comes to comparisons with other cloud service. So as we can see, this is the table show the comparisons of the cloud technology required by this project and the service provided by every cloud platforms. In terms of their pricings, all these 3 pay-as-you-go billings modules, but discrete units or charges. AWS charges per hour, Azure charges per minute, GCP also charges per minute. In terms of coverage, AWS cover 77 available zones within 24 geographic regions expanding across all continents. Azure have a dense coverage among these 3 cloud services provided with 60 regions on all continents. GCP cover is changing closely behind 73 availability zones within 24 regions.
Greetings, my name is Nandizen, ID 18000406, and today I will be presenting about how our solution works and also be presenting about Cognito, Amplify, IoT Core, S3 Bucket, Compare Face, Lambda, and the recognition video. So let's get right into it. Firstly, users must sign in through our Cognito service to get access to our app hosted in Amplify. So this is the Cognito. Let's sign in using this account which I've already registered, and we are granted access to the app in Amplify. In Amplify, users can see which products are in stock. They can also check their carts and also see their receipts when they check out of the store. This is the IoT core code to simulate how a camera sensor would upload a detected face to the S3 bucket when they detected a customer's face. So users must initially upload a selfie or an image of their face, which is stored in the S3 bucket. So this is the bucket right now, and it has a stored image of the customer's face. When we run this code, this means that the camera detects the customer's face and uploads that face to the S3 bucket. File is uploaded successfully. Let's check the bucket, and when we refresh it, indeed there are 2 files in the bucket right now. Next is the compare face lambda. It is configured so that once there is an object created in the S3 bucket, then this lambda will be triggered. The code is written so that it takes the uploaded image in the S3 bucket and then compares it with the stored image in the S3 bucket. If there is a high similarity level within these two images, then it will trigger one of the 3 lambdas. If it is a check-in, check-out, or add-to-cart camera, then it will trigger the check-in lambda, check-out lambda, or the add-to-cart lambda respectively. If the user checks out of the store, the receipt is generated in the app and they are charged accordingly to what they have bought.
Hi, my name is Gayong Hao. My student ID is 1800330. This is my student ID. So I will be talking about the weight sensor, IoT core, weight sensor lambda, DynamoDB for weight, DynamoDB for transaction, and 3 lambda, which is check-in, check-out, and add to cart. First, this is the code to replicate the weight sensor, and it is connected to AWS IoT core. The weight sensor is subscribed to MyWeight1. So we added a rule so that whenever a message is sent to MyWeight1, it will forward the message to Lambda. The message will forward to change product on shelf Lambda. This Lambda will get the message from weight sensor and update the DynamoDB product on shelf. Here's an example. When we run the code for the weight sensor, it will update the database in the DynamoDB. As you can see, the database is updated to the amount that we specified in our code, which is 400. So for the check-in function, when a customer comes into a store, the camera detects the user. It will call this function which add a new transaction in the transaction history database under the DynamoDB. So for example, as you can see, a new transaction is added. So for the add to cart lambda, the system detects the customer taking the product. It will call this function which add the product into the cart inside the transaction database. As you can see, originally is nothing. It will add the item that user take into the cart. Lastly, for the checkout function, when the system detects the customer walk out of the store, it will call this function and update the database status from unpaid to pay. As you can see, the status is changed.
So now I will talk about how to create the quit sign. After we finish the DynamoDB, we need to create the S3 bucket to store the data from the DynamoDB and pass through the data from the data pipeline to the quit sign. So now we go to the AWS. So as we can see, this is the DynamoDB, and we go to the table and we use the product list data. And we can see from this item, there are products in this product list data. Then we will use this data to save to the S3 bucket into the structure management tool. After that, we will use the data pipeline to pass the data from the S3 bucket to quit size. Then this is the quit size we done from this product list. As we can see, this is the data we use, then show into the quit size from the visualizations. If we want to see the mineral water detail, we just click the mineral water. Then all the detail will change to the mineral water. As we can see, all the detail is about the mineral water. That's all for our quiz size. Thank you.